Hi everyone! We are proud to present our capstone project, Digestion, our text classification of Philippine Supreme Court decisions on criminal cases for Digest. Digest is a legal tech startup that aims to help businesses and individuals with their legal needs through easy access to lawyers, contracts, and laws. Legal research is integral to Digest's business model, and this involves sifting through cases to be used in court pleadings or providing advice to clients. And these cases and Supreme Court decisions are not classified, which brings us to the problem we data science fellows wanted to solve. With thousands of Supreme Court decisions categorically unlabeled, how can we use data science tools to save time for these lawyers? So instead of tediously looking through Google for relevant cases, they can spend time refining their case. The tagline of Digest is We make law easy. We aim to make law easier for our lawyers by building a classification model that uses categories to identify and distinguish Supreme Court criminal decisions.
Now for the limitations. Our first limitation is we only classified criminal cases. Our second limitation is we had only limited computational resources because we could only use what we had and some online resources. And lastly, we lack the domain knowledge in law practice because none of us are practicing lawyers. For our methodology, we first got the raw text data from the cases and attached them to the level 1 labels. We then did data wrangling, tokenization, and lemmatization. We then, using the now wrangled data, we did EDA and feature engineering. And that resulted in labeling, modeling, and finally model evaluation. And from that evaluation, we created our level 2 classifier engine. On the right, you can see some of the tools we used as part of our methodology: Pandas, scikit-learn, GenSim, and NLTK. Now for our data sources. Our primary data source was the Supreme Court cases provided to us by Digest. There were over 63,000 cases in that. We also had the law school syllabi and the revised penal code to help us create our criminal cases categories. And as you can see on the right, these are the 14 categories we came up with. For our data wrangling, what we mainly did was remove unnecessary variables. These were HTML tags, formatting tags, GR number, proper nouns, punctuations, stop words, duplicates, and headers. After that, we did tokenization and lemmatization.
All right. So after the data wrangling, the next thing that we did was to identify the keywords to be fed into the model. But before that, let's take a look first at the criminal cases by year. Our data set included cases from 1901 to 2017, and 42% of which came from 1990 to 2010. Also, the year 2000 was the highest number of cases with 699, which is 4.6 times higher than the average of 151 cases per year. Now, let's move on to the keyword extraction. Here, we applied 4 approaches: topic modeling, syllabi, desk research, and consultation with the Digest team. And for us to apply the topic modeling in our EDA, we use 3 models, namely LDA, LSI, and HTP, wherein the LDI has the highest clearance score of 0.50 with 15 optimal number of topics. But during the EDA, we noticed that there's still lots of keyword noises in our models. And with this, we refer to the syllabi, we conducted desk research, and we consulted with the Digest team to come up with the final set of keywords. And it is also noteworthy to add that we explored these approaches for us to come up with the final list of keywords, which you will be seeing on the next slide.
So these are the list of keywords gotten from the EDA. These were the criminal categories that we saw from the EDA and from consultation, and these are the top keywords from those. We ran a script through the data set using rule-based NLP to find those top keywords and label those criminal cases with categories that we took from the EDA.
Now that we have our case category labels, we move on to modeling. We trained 5 different multi-label classification models on our label dataset: ExcelNet, Roberta, BERT, DistilBERT, and logistic regression. Then we used multi-label metrics from the scikit-learn package to compare their performance. Looking at all of our metrics, ExcelNet has the highest performance across the board, with a coverage error of 6.88, LRAP of 82.16, and label ranking loss of 12.11. Next. Shown here are the hyperparameters used in training our deep learning models, as well as the training time, which took well over 8 hours for all 4 models using our personal computers and Google Colab. The number of epochs was also limited by the storage requirement of each pass of the model on the dataset. So, to sum up, did we make law easier for our lawyers? We encountered many challenges along the way, but the predictions provided by our models for the cases in Digest Library have the potential to save clients valuable time in legal research. Still, our project may be finished, but there is more that can be done. With that, we move on to our recommendations. Our first recommendation is to involve the Digest team or other domain experts more in the labeling process. This can be achieved through consultations or through machine learning techniques such as active learning or weak supervision. Second, we recommend using additional computing resources when training the deep learning models. The dataset was quite large, even for Google Colab, so it is suggested to use computers with GPUs for training. Another approach that can be considered is text summarization and filtering the dataset. Third, the classification of other types of cases aside from criminal would be of great benefit to Digest. We would like to note, however, that a different labeling strategy must be developed depending on the nature of the cases under these types. A network analysis of case citations can also be employed to quantify the similarity of cases and build a recommender for Digest. Finally, we recommend the use of other machine learning models which are not implemented due to time constraints, such as Decision Tree, Random Forest, XGBoost, or others. And that concludes our presentation. Thank you very much, and we will now take your questions.